This is the Ratgdo board, and in this video I'll show you how to install it yourself, add it to Home Assistant, and create an automation for it. If you haven't heard of Ratgdo, it's basically a Wi-Fi capable microcontroller that allows you to control your Chamberlain or LiftMaster garage door opener locally instead of being forced to use the limited, slow, and unreliable MyQ app. And if you can't tell, I hate MyQ. My favorite part about Ratgdo is it can be added to Home Assistant, and you can create countless automations with your garage door opener, and I'll go over a few ideas for inspiration later in this video. Right now I'm just going through the components that came with the Ratgdo board, and I've already installed one on my other garage door opener in preparation for this tutorial. And the specific Ratgdo board I'm installing is the version 2.53i control board. And I got the installation kit, which comes with the shown wires and power adapter, pretty much everything you need to attach it to your existing garage door opener. And for this installation, we're only worrying about the red, white, and black connector. I won't be doing anything with the all black wire connector. So let's get started with flashing the required firmware on the board. This Ratgdo board is basically a D1 mini board with a few extra parts, so you could technically write and flash your own firmware too if you wanted, but there's already various firmware available to flash, and since I'm doing a simple integration into Home Assistant, I'll be flashing the ESP Home Ratgdo firmware. Here's the web-based ESP Home installer, and I've included snippets of what my garage door opener looks like, as well as the 2.53i Ratgdo board I'm using to help make the selections before flashing. And make sure you have the board plugged into your computer, install the correct drivers, and use Chrome when doing this installation. Also, for some reason, the screen recorder didn't show the pop-up, but basically it asked which COM port the board was plugged into, and I made a selection before the prompts appeared. And you'll go ahead and acknowledge that everything on the board will be erased so the firmware can be installed. The installation did take a few minutes, so I sped up the video for this part. And once the installation is complete, you'll be able to configure the Wi-Fi which the board will connect to. And I believe you can skip this and configure it later, but I'll just do it now. But you'll basically just select the SSID, type in your Wi-Fi's password, and then it connects automatically after that. After it successfully connects, it obtains an IP address which you can browse to and view statistics about the board. And then this next part, it's kind of specific to my situation. I have a firewall and IoT devices are connected to a separate network. So I just like to go in and assign a static IP address and rename the device. Don't mind all the blurs. That's just me being paranoid. And now it's time for the physical installation. This specific garage door opener is a LiftMaster that's MyQ capable, and here's a layout of the buttons and wiring which I showed a snippet of earlier during the firmware installation. And to start, you'll want to unplug power from the garage door opener. Like I mentioned earlier, we'll only need to plug the red, white, and black wires into the board. Your garage door opener may be different, so don't follow this verbatim if your setup isn't the same. There's also a reference photo showing where the wires plug into the opener. Red goes in red, white goes into the first white terminal there on the left side, and black goes in black. Now go ahead and connect the wires to those terminals. I definitely struggled trying to get a secure connection, so make sure when you're doing this, the wires aren't loose because the garage door opener does vibrate a lot and could rattle one of those wires out of the terminal. And keep in mind, you are not disconnecting any wires that were already plugged into the terminals. Make sure those don't come loose either while you're connecting the board to the opener. Once those wires are connected and snug, you can plug in the power brick and micro USB cable that came with the installation kit. Avoid having the power cable, or any wires for that matter, hang low enough to get caught on the chain or belt. I'm going to loop the power cable through the metal ceiling mount to make sure it doesn't just hang there. And now you can plug the garage door opener back into the power outlet and cross your fingers there's no sparks or smoke. And I'll be coming back up here to put the Ratgdo board in a 3D printed enclosure and zip tie it somewhere secure. But that's it. We're done with the physical installation. Go ahead and press your garage door opener button just to make sure everything works as it should. And the garage door is opening. So let's go back to the Ratgdo's ESP Home webpage to make sure it reconnected to Wi-Fi and verified data is flowing. And the new output here is a good sign. Since I mentioned the 3D printed enclosure, I thought I'd show you what it looks like. I already installed it on my other board, and it looks good, especially compared to an open circuit board. And don't mind the finger in the video, didn't realize it was there until after everything was recorded. Now I want to discuss one of the automations I already set up on the first garage door opener, and apparently only one of my garage door openers have a motion sensor built into the wall button. So I created an automation that will turn on the lights in the garage when motion is detected. I highly recommend looking at what triggers are available for your opener, but in this case, the trigger is when motion is detected, I make sure lights are already off, and then I turn the garage lights on. And then I have a separate automation that will automatically turn the garage lights off. So when the light built into the garage door opener turns off, it will turn off the rest of the garage lights. I added an extra condition to make sure my Reolink fisheye camera that's inside the garage doesn't detect a person, so it won't turn the lights off if someone is in the garage. Here I'll demo what the automation looks like in action. Most of my light switches are Brilliant brand, but the one in the garage is TP-Link Casa, which I have integrated with Home Assistant. So you can see the current state of the garage door opener light and sensor in the bottom left corner. And when I walk into the garage, the sensor changes to detected, which now turns on the garage lights, whereas it would originally only turn on the built-in light in the garage door opener. Here's the TP-Link Casa smart switch. And the button here on the right side is the one with the built-in motion sensor. I currently have Zigbee door sensors throughout the house.
Interior garage door open.
And as you could hear there, our Google Home Mini announces when doors are opened. It's like a low-cost, self-managed ADT system. An automation I'm thinking about adding in the future is announcing when a garage door is opened or closed. Other ideas I've had is detecting a specific sound through the camera in our garage, like the sound of a car engine when I remote start it, and then partially opening the garage door to vent the garage while the car is heating up. I can also now ask Google to open or close the garage doors for me, all through Home Assistant. And you can see here the button for the main garage door does not detect motion, whereas the other one on the right side does. I could also set up more reliable GPS location tracking so the garage door will open or close as I approach or leave the house. But the response time is immediate, which I love. When I control the garage door via the Home Assistant app, there is no latency. And the great part is MyQ still works if you want. I hope you found this video helpful, and thanks for watching.